Okay, so like I said, you should have the guided notes open, and it should be blank, and you should see spots where you can fill in different answers as we go through. So again, the notes are in the week 4 folder. Click on the Nearpod notes for force and force diagrams. So this is the second type of Nearpod that we'll be doing. So I said we'll be doing 2 types of Nearpod. The first type is one where you just participate and follow along and just engage in the lesson. That's the first type, and you get points for that based on your participation. This is type 2. This is guided notes. So as I go through the lesson today, there will be words that you will need to fill in that match your worksheet. So as you go through, those words will be in bold, or they might be in a different color. I will explicitly point them out to you. That's, hey, this is a word. That's what you need. But if you're following along and paying attention, you'll pick up on that before I even say it. So those words, this stuff represents the key concepts and really important things that you need to understand for the material that we're going through. And today we're starting with forces. We're getting into the real science that we are going to be covering this unit. So when we are done with this, you'll submit this on Schoology under whatever the correct assignment is. So you'll go back to Schoology and click that big white submit button when you're done. So hopefully when we finish this, you should be done and ready to go right when class is over. If not, you can continue to work on what you're missing. There'll be a link in the document to go to a self-paced Nearpod where you can do it at your own pace. You might be able to go back and fix anything that might be missing. All right, so I'm going to go on to the next slide that will have information on it. So like I said, we're going to talk about force and force diagrams. So forces are anything that creates movement or causes things to change shape or position. And we're going to get into that. So you've probably heard of the word force before. It's something you've definitely come across and have used probably towards somebody else, whether it's you're forcing me to do this, or I'm going to, doesn't have enough force to open the jar, things like that. So force is something you should have heard before and probably even use in your daily life. So what is force? All right. Force is something that causes a body to change its shape, motion, or direction. And it's measured in a unit called newtons. So, some of you guys might get the picture that I have down there. It's supposed to be a GIF, but it's not working, as I can see. But everyone says use the force, like in Star Wars. It's a slang term in that movie, but it actually applies motion. It's a force. It's something that applies motion and a direction in the movie itself. So it actually does follow the definition. So what's in orange is a force is something that causes a body to change its shape, motion, or direction. That is what goes in the notes. I'll give you a second to type that in while I clean up my notes. So you should be typing in a force is something that causes a body to change its shape, motion, or direction. So some examples of this are push, pull, gravity, and friction. So push, pull, gravity, and friction. So a push or a pull are generic terms for making an object move in a direction. You can either push an object forward or you can pull an object to you. That is applying a force that gives something motion in a direction. Gravity is a very specific force that is related to our planet. So gravity is something that is based on your mass. Is what gravity then gravity creates a force based on your mass. So if you were on the moon is much smaller than the Earth. So if the moon were to would pull less gravity on you. So that's why like people on the moon, you see them like jumping or things floating because there's not as much gravity on the moon as there is on Earth because of its size. So because it has a smaller body, it's pulling on you less. Friction is something that opposes all motion. So whether you're rubbing your hands together and you feel that heat, or you try to slide your phone across the floor on the carpet or the hardwood, it'll eventually come to a stop because the floor or the carpet is pushing against your phone as it slides across. Now, as it slides across, it's going to be all those little carpet fibers or wood is going to be touching and pulling against the phone, which eventually will slow it down. So that is actually a force. So that is what you should be writing down for force and the examples. So what you can do, no, that's not gonna let me do that. Okay. All right, so if you're looking at my screen, this is what you should see, it with yours anyways. So I'm following along on my own notes that are separate from yours because otherwise it'll overwrite what you guys are writing, which is not great. So this is what you should see, or what your notes should look like right now. You have these two things filled in, and you have the notes correct. All right, so if you have this, give me a thumbs up in the chat. Let me know you're good to go, and I can move on. You type it in the document that you opened. So you should have it, your document that you opened on the Schoology page, and that is where you type in the notes. All right, if you need more time, put in need more time in the chat. If you're done, give me a thumbs up. All right, so Amelia, you need to go into the, let me pull it up. So week 4, forces in motion, and then it's this one right here. Then you're gonna type directly into this document. So when you open up my document, you're gonna type directly in here. When you open up that, there's going to be a tab that says My Document, and that's what you need to click on. All right. Excuse me. All right, moving on. All right, so whenever we have forces, forces can be balanced or unbalanced. And every force works this way. So when you have equal forces, they are called balanced. So when things are balanced on a scale, it's the same on both sides, so that scale stays flat in the middle. But with this, what happens is there's no motion instead. So when forces are equal, they cancel each other out. So as you can see, equal and cancel are in bold. That's what goes in the blank. Right? There's no change in motion and no acceleration. All acceleration is a change in speed. So if you are going from a sit to and now you're walking, you're changing speed from nothing to motion. So that's acceleration. This is actually how your computer is sitting on your lap or a desk right now, or it's how you're sitting on a bed or your chair right now, because you're not floating away into space, because the chair is exerting force up as your weight exerts force down. So those balance out, and that's a balanced force, so there is no motion. So balanced forces are when they are equal, and when they are equal, there's no motion. Tug of war is a really good example of this because it shows us that both sides, no matter what, are not moving. So when you have equal forces on both sides, no one's going to move. So you only can win tug of war when one side exerts less force on the rope than the other side and pulls them into the middle. So on your paper, what you do for these blanks is you double click on the blank where it's highlighted, double click, and it'll highlight itself, and then forces are, the first blank is equal, E-Q-U-A-L, and then and cancel each other out, so you double click on that. And then the next one is double click, no change, no acceleration. That's how you fill in these notes. So that way, when you go back to review this, you can see what you filled in and what the important parts are. All right. Next up, if you can probably guess, if we've had balanced forces, now we got to talk about the other side where the forces are unbalanced. Unbalanced or the forces are not equal. This is really important because this is how all motion works, is when the forces don't balance out, you get motion. Whether that's you walking or driving or throwing something, when forces are unbalanced, you create motion. So, for example, in this first one, the tug of war, you see the guy on the left in the red, he is pulling with 50 newtons, and the guy on the right is pulling with 30 newtons. So the guy with the 50 newtons is going to pull harder and with more force, therefore pulling the guy with 30 newtons, the smaller force, in his direction. All right, same with like cars. So cars have a weight and they don't want to move. If you ever try to move a car, it doesn't move very well unless it's on and driving, and it exerts a force in the opposite direction of the weight, and then that creates motion. Unbalanced forces, and these forces is literally rocket science. You may have heard people joke about, well, it's not rocket science. Well, this is rocket science. So a rocket has a weight and a mass, and it's exerting force down on the ground. Like when I told you, when the force of the ground is equal to the force of what's pushing down on it, you're not going to have any motion, which is why you're able to sit in the chair you are. This is why I am not falling through the floor, and this is why you can't walk on water. Because when you try to step on water, you push down on a force that's equal to your mass, and then the water tries to push back but cannot push back with enough force, which is why you go kerplunk and you go into the water. So with a rocket, with the newtons of the weight of the rocket is holding it on the ground, the rockets have to provide enough thrust, enough force by channeling large explosions towards the ground, which creates force in the downward direction, which is then pushed back on in the upward direction with a greater force than is what's holding it down, and then it starts to fly in the air. This is literally how rockets work. So what you should write down in your notes is it's not equal, and there is a change in motion. So the main takeaway from this is that balanced forces equals no motion, and unbalanced forces equals motion. When you have unbalanced force, the object accelerates in the direction of the force, and when something accelerates, it creates an increase in speed. All right, so let's see how we're doing. You have 30 seconds to answer this, so make sure you answer it quick. If you apply an unbalanced force to an object, what happens? It decreases, it stays the same, it increases then decreases, or it increases and causes motion. So what happens to the acceleration? Come on, guys, be quick. Yikes. All right, guys, you have to be paying attention to this. Please, please, please pay attention to this and hit submit before the time runs out so you get credit for it. All right, so I'm going to look at the results. All right, so let's see. All right, we did not do this, or we did not do very well on this. So I'm gonna need to go back. All right, so it says, remember, look at your notes. There is a change in motion if the forces are unbalanced. If these guys up here are pulling with 30 newtons to the right and 50 newtons to the left, the 50 newtons has a stronger force, so it's going to pull in that direction. All right, think of a scale. When the scale is unbalanced, the scale moves in the direction of the heavier object. So balanced forces don't have motion. Unbalanced forces cause motion. So an unbalanced force will create motion. So if you apply an unbalanced force to an object, what happens to the acceleration? All right, better, but still not perfect. All right, so is this balanced or unbalanced? And draw an arrow in the direction that it'll move. So you remember you can draw by clicking and dragging. See what my mouse is doing right here. All right, you can draw that. So in what direction is this box going to move? All right, so just use the size of the arrow to determine the force, okay? So which arrow, you should be able to look at this and see which arrow has the greatest force. So again, we have 4 forces acting on this box. You have force B pushing down, that represents gravity. Force D, force pushing up, that can represent a table. Force A is pushing to the right, and force C is pushing to the left. So what direction will this wind up going? So you can see that these forces are equal, so they're going to cancel out. It's going to keep it moving in, it's not going to move in the up and down direction. But you can see that force C is a greater force than force A. So it's going to move it, this whole object, in this direction. All right. Good job, guys. Make sure you guys hit submit when you're done, otherwise I can't see it. All right. So right, it'll move, this box will move to the left. Good. So there's 6 types of forces. All right, 1, gravity. It's the attractive force of anything with mass. So like I said, the Earth has mass, and it is way more massive than you or I, right? We often confuse mass with weight, and weight is actually a combination of mass and gravity. So your weight is how much gravity is affecting your mass. So if someone has a lot of mass, meaning they're a very big person, they're going to have more weight because there is more gravity pulling down on them. Versus the opposite, if you're not a very big person, then you're not going to have as much gravity pulling down on you, and you're going to weigh less. The normal force is something that pushes back at any surface that pushes back. So for example, your cell phone sitting on the bed or the desk right now or the table is not moving, all right? But it would move if the table didn't exist. So the table or The normal force is pushing back up on your phone, and gravity is still pulling your phone down. Because if you were to pick your phone up and drop it, it would move down. You don't want to do that. So you keep it on the table, and the table pushes the normal force up, and the phone pushes the gravitational force down. And they stay balanced, so there's no motion. A push or a pull is an outside force. So in order to slide your phone across the table, you're going to have to apply force to it. Or you could attach a rope to it and pull it. So a push or a pull is an outside force applied to an object to create motion. Friction is anything that goes against motion. So we have two types of friction, regular friction and air resistance. So regular friction is, again, I'm going to use this phone sliding across the desk analogy, because if you slide it across the desk, it's going to come to a stop. And when it slides across the desk, the friction of the table is going to slow down the phone. So as it slides across the table, it interacts with the surface, and those forces oppose each other, which ends up slowing it down. Air resistance is the friction that the molecules in the air push back against things that move through the air with. So if you are driving in a car today, put your hand out the window. What you're feeling is air resistance. I know you can't see the molecules in the air, but they are smacking against your hand and forcing, you're moving this way with the car, one way with the car, and the air resistance is smacking against your hand and pushing your hand back. And that resistance is air resistance. So that's another form of resistance that can happen that causes motion. And finally, tension. Tension is something that's in a rope or a wire or a cord, kind of like a rubber band. If you pull a rubber band apart by the ends, you can feel the tension in the rubber band. If you let go of one of the ends, all right, all that built up tension is now transferred into motion, and it causes the rubber band to move if you want to fling it. So that tension is what holds up ropes and wires and other objects. Now we're not going to talk about tension so much, but we're going to use a lot of the other ones frequently. Make sure you put this in your notes. So again, your note should look like this. All right, every blank is now filled in where it was highlighted by double clicking on it and typing it in. Right, Johnny, I just saw your message. All right, so let's talk about these ones right here. So if you apply force to an object, what happens to its acceleration? Can you answer that in the chat? If you apply force to an object, what happens to the acceleration? Come on, somebody answer. If you apply force to an object, what happens to the acceleration? So force is applied and creates an unbalanced force. So if you apply an unbalanced force, remember, if you go up, unbalanced forces create motion. So your acceleration will increase. When your acceleration increases, so does your speed. So if an object accelerates, what happens to your speed? When an object accelerates, speed increases. So we talked about this in that last problem we did where you drew on the screen. And some of you guys picked up on this already without even doing anything with it. So these are called free body diagrams. We saw this in that problem we drew. So we're going to see a lot of these and do a lot of practice with this, where we're going to show all the forces acting on an object and then determine its motion based on that. So the forces that are acting on an object in all directions. Forces that are acting on an object in all directions. So you can see that you have force C, which is larger, so this object would move to the left. Over here, these are where all those forces come in. So we talked about we have a normal force. That was what we talked about. We have the applied force, which is a push or a pull. Force of gravity pulls down, and the force of friction opposes the motion. So these are the four regular forces that we're going to be talking about pretty frequently. You have the applied force, which is the push or pull. You have a gravitational force. You have the normal force, which opposes gravity. And you have the friction force, which opposes the push or pull. Now, it doesn't always mean that they will go in these directions. You can switch the friction and applied force back and forth, and it'll still read the same. On this one down here, this bottom one, you can see that the normal and the gravitational force cancel each other out. So you won't have any motion in the up and down. But to the left and to the right, you will have motion because 20 is greater than 3. So it'll move to the right with 17 newtons of force. So forces will be the last part of your fill in the blank. All right, so go ahead and try out this exit ticket. And then after this exit ticket, we are done for today. All right, so that's all I got for you today. So you can go ahead and submit this assignment on Schoology. If you need help with it, or you didn't understand it, or need me to explain something, come to my office hours today. They are from 11 to 11:50, or from 2 to 3 o'clock. So make sure you come to there if you need it. Let's see. All right, so if you didn't get all the notes, there is a link in the top of the notes that says Nearpod, or it's in the assignment itself. Go there, and then you'll be able to scroll through the notes at your own pace and pick up anything you missed, and then you can turn it in complete. Again, if you have any questions or need any help, come to my office hours, and I will be able to help you out there. But other than that, that's all I got for you guys today, and I will see you guys on Wednesday.